Welcome to Limits, Lesson 4, Continuity at a given point. Alright, first thing I'd like to talk about continuity. Yeah, there's a big problem, isn't there? Because I think we have a moratorium on pentasyllabic words. And since continuity is a pentasyllabic word, because of the moratorium, I don't think we're allowed to use it anymore. Hey, I don't know. We'll talk about that in class. Now, here's your lame joke for the lesson. Are you ready? Hey, do you want to hear about the joke about limits? Sure, you say? D-N-E. Sorry, that one just made me laugh, so here we go. Continuity at a given point. You have a piecewise function here, f of x equals negative x, where x is less than negative 2. That would be this line right here. F of x equals x squared between negative 2 less than or equal to x, which is less than 0. That would be this part of the parabola right here. And then f of x equals x minus 1 for x greater than or equal to 0. That would be that linear part right there. It's actually a ray. Alright, let's review what we learned yesterday. What is the limit as x approaches negative 1 of f of x? So what we're looking at right here is right here at negative 1. What is that limit? From the left, it looks like positive 1. From the right, it looks like positive 1. I'm going to have to say that the limit on that is 1. How about the limit of f of x as x approaches 0 from the right? From the right, it looks like we're approaching negative 1. That is the y value. How about the limit of f of x? Oh, sorry about that. The limit of f of x as x approaches 0 from the right. Looks like it's coming down right here. It looks like it's going to be 0. So, what is the limit of f of x as x approaches 0? Hey, didn't we just talk about that? Does not exist. That limit does not exist because it's not the same from both the left and the right. So what does that have to do with continuity at a given point? At right here 1, the function is continuous. At 0, the function is not continuous. It's got to jump, a break, a hole, or something like that. We'll talk about what kind of terms those are as we move along. Actually, we'll talk about them. Nope, not the screen, the next one. Let's go ahead and move on. Continuity. A function is continuous at a point x equals a, some value of x, if the three following conditions are met. F of a is defined. The limit as x approaches a of f of x exists. And f of a equals the limit of f of x as x approaches a. Go ahead and pause that while you write that down, and I think I'm going to do some doodling while you're writing this down, so go ahead and pause it. Alright, I definitely felt like Elsa on that last one, putting stars and snowflakes all over the place. That was kind of fun. Alright. Let's look at these three things. I know you've got them written down. Let's go look at those at the previous screen, alright? So, okay, what was f of negative 1? F of negative 1, put a negative 1 in there. No, sorry, f of negative 1. That's in this slot right here. F of negative 1 is negative 1 squared. That's 1. And the limit as they approach are both also 1. So therefore, it's continuous at negative 1. All right. Oh boy, did I have fun writing all those cool things. Okay, let me get that pen back, the real one. Alright, let's talk about discontinuity. Discontinuity terms. You've got removable, and they're either a whole or a disk. Red is removable. That's the red one. That means f of a is defined, but it is not equal to the limit as x approaches a. Okay, the black one right here, that is a whole. It's defined everywhere, but not at one particular spot right there at 0. So there is a hole there at 0. And then the two non-removable discontinuities. Yes, I know. I bet you didn't even know that that was a term. And you know what? Maybe we shouldn't be using it. It's a pentasyllabic word. Non-removable. There is a jump discontinuity, non-removable. That's where the function's going along and it's like, there's a hiccup, and then it jumps, and then it continues. Yeah, there it's continuous. But right here at this jump, it's not. And then there's a non-removable that's asymptotic. That's where there is an asymptote, or two, horizontal and vertical, or maybe two verticals, you know, whatever. That would also be a non-removable discontinuity. Those are the 4 discontinuities that are possible. So let's go ahead and move along. Hey, we're almost done. Alright, f of x is another piecewise function. Kx plus 6 for x less than 6, and x squared where x is greater than or equals 6. Find a k, some number there, so that f of x is continuous at x equals 6. So for that piecewise function, we want to set those two parts equal to each other. Kx plus 6 equals x squared. And we want it to be continuous at x equals 6. So everywhere we see an x, we're writing 6. So 6, that's a terrible 6, don't you think so? 6k plus 6 equals 6 squared. Where did the 6 come from? Because x equals 6. Now we're going to solve for k. Yeah, I know I switched the orders of those two. 6k plus 6 equals 36. Subtract 6 from both sides. 6k equals 30. So k is going to have to be 5 so that it is continuous at 6. And you'll have several problems like that. I hope you took good notes and kind of figured that out. Hey, that was a short, quick one. I think we're done. See you tomorrow. Have a good evening.